Okay, your notes for today, Linear Inequalities Part 2, is very, very much like the last notes that we did on linear inequalities, where you graph and you have solid lines and dashed lines and you shade above and you shade below. So a lot of this will be review, which is good. So if it was confusing, then maybe today it will click, and if you kind of already understand, or you do already understand, hopefully this will set it in stone like cement in your brain. Here we go. Steps for graphing a linear inequality. We solve for y, if necessary. We plot our slope and y-intercept. This is just review here. I know if there is an equals, I am going to draw a solid line. And if it's less than, I'm going to shade which way? Below. This one does not have an equals, so this will be a dashed line or a dotted line. Because it is less than, I shade below. This one has an equals, so it is a solid line. And because it's greater, I'm going to shade above the line. This one has no equals, so it is dashed or dotted. And because it's greater, I shade above. I'll review. Okay, sometimes in our solving for y process, we may divide by a negative number or multiply by a negative number. So remember, we have to flip the inequality sign when you divide or multiply by a negative number. So don't forget that little rule. It is really easy to forget. But that is when we flip our inequality sign. Okay, here we go. Number 1. This is not solved for y, so I must do that. So first I'm going to circle everything smushed with my y. Whatever is outside the circle, I add or subtract. So I'm going to subtract x from both sides. My y drops down. My symbol drops down. I always recopy the x first. It is a minus x, and it is a positive 2. I do not need to flip the sign because I never divided by a negative or multiplied by a negative number. Okay, first thing I always plot is my y-intercept. My y-intercept's the number behind the x. So I plot my y-intercept on the 2 on the y-axis. My slope is negative 1, which is understood to be over 1. So that means down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Or I can reverse it and go up 1, left 1, up 1, left 1. Is this a solid or a dashed line? Dashed. There is no equal sign, so dash, 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 dash. Because it is a less than, do I shade above or do I shade below? I shade below. Then I want to know if these points are in the solution. So let's check. 0, 0. Going to grab a black marker. 0, 0 is right here. It is in the shaded section, so yes, it is a solution. 5, 0, I go right 5. Stay put. It is not in the shaded section, so no, it is not a solution. 0, 2 is just up 2. It is on the line, but because it's a dashed line, then no, this is not a solution. Okay, everything so far. I'll review. Hopefully this is easy peasy. Lemon squeezy. Number 2. I circle everything smushed with my y. I will add or subtract whatever is outside that circle. So to remove the minus x, I must do the opposite and add the x. My negative 2y drops. My symbol drops. I recopy the positive x. I recopy the positive 4. Then I have to divide by whatever's in front of y. So I divide both sides by negative 2. Because I divide by a negative, what do I have to do with my inequality sign? Flip it. Now, remember, this has a 1 in front of the x. You just don't see it. You cannot reduce 1 over negative 2, so it's going to stay that way. I just don't like to put my negative in the denominator, so I'm going to put it up in the numerator. But if any of you left it 1 over negative 2, that would be fine. And then 4 divided by negative 2 makes how much? Negative 2. Okay, which of these numbers is my y-intercept? Negative 2. Hopefully all of you are answering my questions. Don't be quiet. Don't be shy. Plot your y-intercept of negative 2 on the y-axis. The slope is negative 1 over 2, so that means down 1, right 2, down 1, right 2, down 1, right 2. Or reverse. What would reverse be? Up 1, left 2, up 1, left 2. Is it solid or is it dashed? It is solid. Do I shade above or do I shade below? And because I switched my sign and it's less than, okay, now we're going to see what's a solution. 1, 4. I go right 1 and up 4. Is 1, 4 in my shaded section? No, it is not. So you are not a solution, Mr. 1, 4. Negative 4, 0. I go left 4. Stay put. Is that a solution? Yes, it is. It's on my line, and it's a solid line. So, yes. Negative 1, negative 5. I go left 1 and down 5. Boop, 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 boop. Is that in my shaded section? Yes, it is. So, yes, negative 1, negative 5 is a solution. Front page done. Let's give it a smiley face. All right, flipping our paper. Okay, this is new to us, but it should be easy. It's combining some skills that we have used in the past. We're going to try to write an equation for the line. I know because this is a diagonal line that I know there's going to be a y and an x in the equation, so I need to make my equation look like this. But I will not use an equal sign because of the shading. So I'm going to have to figure out if it's going to be less than or greater than, etc. So first of all, let's find B. B is where the line crosses the y-axis. Here's my y-axis. Can everybody see where that line crosses the y-axis? It touches it right there at 0. So I can put a plus 0, or I could just not put anything back there. Okay, then I need to see where my line goes through corners of boxes. So here's a box, that's a corner. Here's a box, that's a corner. So slope, you count rise over run. So I rise 2, I run 1. So my slope is rise 2, run 1. Don't forget the x, don't forget the y. But I'm not going to put an equals. So is the line solid or is the line dashed? The line is solid, so it will get an equal sign. Is the graph shaded above or below the line? Is this shading above the line or is this shading below the line? This shading is below the line. So which inequality symbol should we use? Below is less than. And this is our answer. And I could just simply write it as y less than or equal to 2x. I don't have to put the over 1 and I don't have to put the plus 0 in the back. I can, but not necessary. Chooka, 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 chooka. And that is the equation of our line. Okay, let's try it again. Number 4. I know because it's a diagonal line, there's going to be an x and a y in the equation. So this is how I want to make my equation look. First, let's find the b, the y-intercept. Can everybody see where that line touches the y-axis? Where is it? Right up here at a positive 5. So I'm going to put plus 5 in the back. Next, I want to find my slope. So I need to see where my line goes through corners of boxes. Does this look like a corner of a box? No. Does that look like a corner of a box? Nope. Does that look like a corner of a box? Yes, it does. So to find my slope, I count my rise over my run. What do I rise? What do I run? up 2, right 3. So my slope is 2/3. I recopy the x and the y. Okay, is this a dashed or a solid line? It is dashed, so there will be no equals. Is the shading above the line or is the shading below the line? The shading is above the line, and since the shading is above the line, we need to use greater than. And there it is. That is our inequality for the graph. Fun, right? Totally. All right, we're almost there, folks. Number 5. Zane is buying peanuts and cashews for a party. He can spend no more than $24. Peanuts cost $2 per pound, and we're going to use X for peanuts. Cashews cost $3 per pound, and we're going to use Y for cashews. Okay, so how can I write that peanuts cost $2 per pound? 2x plus he's buying cashews. How can I write that cashews cost $3 per pound? 3y. Okay, and here's the important part. Zane can spend no more than $24. Can he spend exactly 24? Yes, he can. So let's give it an equals 24. Can he spend more than $24? Nope. Has to spend under $24, less than $24. Okay, so it tells me solve for y and graph. You betcha. So I circle everything smushed with my y. I add or subtract whatever's outside my circle. So to get rid of a positive 2x, I must subtract it. The 3y drops. The symbol drops. How do I rewrite this? Tell me out loud, everyone. Negative 2x plus 24. How do I get rid of that pesky little 3? Tell me, everyone. Divide by 3. Will I flip my inequality sign? No, I will not. I'm dividing by a positive, so no flipping. Negative 2 over 3 does not reduce, so I leave it negative 2/3 x. Does 24 over 3 reduce? Yes, it does. It makes a positive 8. Okay. Which of these numbers is our y-intercept? The positive 8 is our y-intercept, so I go to 8 on the y-axis and I plot that. My slope is negative 2/3, which says go down 2, right 3. Pay attention to your scale. Do you see how it's going by 2s? So going down 2 puts me right here, and then going right 3. Pay attention to the scale. It's going by 2s. So here's down 2, here's right 2, here's right 3. It's halfway between the 2 and the 4. Okay, I'm going to go again. Down 2, right 3. Puts me right here, because that's 1 and another 2. Down 2, right 3. Okay, would this be a solid or would this be a dashed line? It will be solid because of the equal sign. Ooh, I did not draw that very straight. Okay, will my shading be above or below? Less than says shade below. Which way is below? This way. Now, let's see which of these are a solution to the inequality. 2, 8. Let's see if it's in the shaded section. I go right 2, I go up 8. Is 2, 8 in that shaded section? No, sirree Bob, it is not. 4, 6. I go right 4, I go up 6. Is that in the shaded section? No, it is not. And what about 8, 2? I go right 8, I go up 2. Is that in the shaded section? You betcha. So that is a solution. This was so much fun. Give it a smiley face, everyone. Thank you.